In Boujou, we will import our image sequence by pressing File on the top left and clicking on the first image, and then change the frame rate to the frame rate of the video, which in my case was 59.94, and press Apply. Now I will mask out the area that I want to track. So everything that is in the green will not be tracked, but I will invert the mask, and so only this pavement area will be tracked. Now we track the features, go into the Advanced tab and just manipulate the sensitivity and press Start. And now you can see it is being tracked. And once tracked, it will be solved, and all these points here are should be stuck to the ground. We will now determine for the program to determine the scene geometry. I will click on 2 points for the x-axis, change the type to x-axis here, and connect to selected and update the coordinates. And now I will do one for the z-axis. Click on the first point and the second point, and now change the type to z-axis and connect to selected, and make sure you update coordinates as well, and also one for the origin. So add coordinates from hint, type, origin, connect to selected, and again update. Now to make sure this has worked, let's do an add test object to see if it sticks to the ground, and as you can see it does. Now all that's left to do is to export this project. Now I've opened up that file, the one that we saved from Boujou, and I'm checking it in Maya. I'm going to make sure that all the trackers are sticking as they should be, and then this part here is optional, where I just group them all and scale them, and then just change the color of the trackers so that it's more visible. And now in the 4 view mode, I'm going to use a curves tool to shape the footpaths. As you can see, I'm using all 4 views to see how the shape is turning out, so I can follow the path. I will do that for the left side and then the right side. And now I will grab the 2 curves and go to surfaces and loft. Now I need to convert this from a NURBS to a polygons, change it to quads and hit apply. Then I'll reverse the normals, and this is how it should look. This will now be exported over to Houdini, where I will do the ground cracking. So now we'll import the mesh into Houdini. And you can see it's stuck onto the ground. Now we'll add a UV texture node. And this will act to serve as the one image that will stick onto the road surface. So we'll change the texture type to perspective from camera, and we'll need a single image. So to do that, we'll duplicate the camera and paste it onto the front here in object level. And what we'll do is we'll change the title to camera no animation or something like that, and we will disable well, first of all, let's just we'll delete the transformations for the animation. And then in the UV texture node, we'll add that camera into the camera tab there. and we'll change the camera view to the original camera, and now you can see it's stuck to the ground. This helps for the fractured area. Now in the material palette tab, we'll have to create a constant material, and in that material we'll choose a single image which will act to be the one that will stick to this path. And back into the NURBS to poly area, we'll add a material node and add that constant shader, and as you can see, it's stuck to the ground. That's one single image stuck to the ground. Now what we need to do is add more resolution to the road path. That will make our curve, what we're about to make after, a lot more easy to see. And now we'll make a curve node, and then with this curve node we're going to shape our fracture, how we want to fracture the road. As you can see, this is my shape here. And I will add a resample node to give it more points, just to make it more smoother. As you can see, we've got more points now. And now we'll get the attribute transfer node and hook up these color nodes like this. And in the attribute transfer node, go to the conditions tab and change the distance threshold until you can see your curve. Yeah, because I've got my points up here, you're not able to see it. Let me just change the view and take off these points. You can see the curve node there, but it's not smooth enough. But let me just get the right sort of width. And now I'll add a smooth node. And this should smooth it out when I change the settings up here. I'll need to change the attribute to CD and then adjust the strength. And now we'll get a scatter node and change the density attribute to CD. And you can see these points here are the points that will be fractured in the RBD material fracture node. As you can see here, I'll hook it up onto the last node and then the subdivide node into the first input, and at the moment you can't see where the you can see the fractures evenly distributed, which is not what we want. So in the RBD material fracture, if we go down to the input points and tick that on, and you can see now this area here, it changes to our curve shape. Now we'll get an RBD configure node. This will affect which area to be active and which area not to be active. So I'll create a few boxes which will act to serve as the areas that should not be, should not move basically when the bullet solver is doing its thing. You need to make sure that it's in bounding type is bounding geometry, and we need to check on active and use bounds. Now the green area is the area that's going to be affected. Now we've got the RBD solver node in place, If we just check off the glue constraints in the RBD material fracture and in the RBD configure, turn the active to 0. So that green area there will be the area like this that is affected. I hope this helped.